And if they won't play, I'll just explain what was going to be in the video, so you have to bear with me. I'm actually standing in today for Ben Cushing. If you want to get a hold of Ben or myself at the end, feel free to come up to me afterwards and I'll get you the appropriate card information. So what are we talking about when we say AI at the edge? Everybody has kind of a different definition when they say edge computing. When you think about AI, you often think about lots of computers in a big data center, which is definitely in the context of AI, but also where else can we run AI? So when I say the edge, I'm talking about the far edge. Today we have OpenShift clusters running on the International Space Station doing DNA sequencing and analysis that links up with another OpenShift cluster at NASA down here on Earth. And so you can, if you can imagine, it runs with the amount of power they can get on the space station. There's another project going in on the moon before long. And so we can run there, we can probably run back in a Humvee or in a sparse environment pretty well, right? So this is an example of a disconnected edge device. We did a demo of this a few years ago at HIMSS. This device actually rode with the person doing the demo in the overhead bin of the airplane that they were in. This particular demo we were doing had to do with sepsis detection at the edge, and so it was able to run all the horsepower that it needed right there next to the patient bed. So why should we automate healthcare? Why should we automate any aspect of healthcare, I should say? Well, there's this concept of hyper-automation. Hyper-automation essentially means automating everything in an organization that can be automated, which in healthcare is so important because there's a lot that cannot be automated, or at least not automated very well. But if we automate everything that can be easily automated, then we leave room for the things that cannot be easily automated. Those on-credential level tasks that clinicians need to be focused on, what if we can automate away all the things that aren't on credential level to give you back the time, the energy, and the mental focus to be able to focus on those things? So I'll talk a little bit today also about clinical guidelines and clinical protocols. It's really important to have guidelines and processes defined. If you're going to automate something, you can't just randomly do that. We need to understand what's the process behind what we're going to say that we're automating. And really this enables us to consider a learning health system. So a learning health system, if you're not familiar, is the idea of iteratively learning, creating processes, and then executing those processes, learning from the outputs of the process, learning from external environment variables and external information, and improving continuously. A quick plug for BPM Plus Health. If you're quick, you can grab that QR code. BPM Plus Health is a very key organization that's nationwide, part of creating clinical process guidelines and actual process documentations in BPM notation that can allow us to automate and implement these automations in a healthcare setting. And if you don't catch it, come up to me after, I'll give you the URL. So when we talk about accomplishing anything important, we often ask ourselves, where are we now? How did we get here? Where are we trying to go? How are we going to get there? Our good friend Shane McNamee coined it this way: data is the information about how we got here, that's in the past. Knowledge is important for right now. I have a patient in front of me now, I better have the knowledge to deal with that. Process is how I'm getting where I'm going from where I am to the patient's goal. So I'll talk about the rest of the presentation and really in light of these three main things: data, knowledge, and process. What if we could prompt an AI to give us the data that we need? What if I could prompt an AI to give me knowledge I don't have right now in a key environment, a key situation? Let's say I'm medevacing a patient someplace and I don't have the knowledge that I need to deal with an emergent issue that I have. What if I could prompt an AI to help me out while I'm on the way? What if I could prompt an AI for the process to follow after I apply the knowledge? So prompting for data. We have an example patient that we created. This is Tommy. Tommy's 14 years old. Tommy's parents are stationed overseas and he's seeing a pediatrician today. He's come in with a slightly elevated blood pressure and some other factors. I want to see if this video will play, and of course it will not, but that's okay. If the video had played, what you would see is the clinician prompting the AI to say, okay, it looks like Tommy, I'll go back to the picture, Tommy has a little scar on his chin there. How did we get that scar? Tommy's mom says, well, Tommy was in the hospital a few years ago on such and such a date, and he had stitches. Okay, well, I'd like to know more about that. So the video is prompting the EHR. I could just go look up in the EHR what are all of Tommy's records. I'll spend a few minutes, I'll get back to you. Or I could just say, when did Tommy have stitches? And then the EHR is being queried in the background. It's actually pulling up in 5 seconds. Tommy had stitches on this date at this facility. This was the cost of it. This was the physician that did it. Everything that I would actually want to know about that, I get in a few seconds instead of having to spend a few minutes looking it all up. Now, how do we do that? So you probably heard a lot about large language models and fine-tuning models, and you can do all of that, but fine-tuning a model is really, really expensive. It requires a lot of horsepower, a lot of compute, and it's kind of slow, so by the time you have your fine-tuned model, it's kind of out of date if you cared about something that happened yesterday. So timely data is important. Also privacy. Unless you have the facility to fine-tune that model on your own, you're stuck with shipping all of your patient health data to a third party to have it fine-tuned on their facility. So now you have to worry about HIPAA compliance and FedRAC compliance and all of that around it. So there's a better way. So if you haven't heard about this, this is a very important area in large language models. It's called RAG, Retrieval Augmented Generation. So what I'm able to do with RAG is take all the data that I have, the documents about a patient, the documents about my process, any document that I have, I can vectorize those documents, create basically a mathematical representation of all the documents that I've got, and provide that to the LLM. So LLMs are actually really good at talking, but they don't know really what they're talking about a lot of the time. If you've ever tried using some of the popular tools to write a paper, you know that if it'll say something that sounds authoritative, it may have made it all up, you don't know. So RAG helps the LLM actually know what it's talking about. So now it can be good at talking and be knowledgeable. So this is a really exciting part. What if I could do that with FHIR? You know, FHIR records are actually meant to be connected entities. You get all this information in a FHIR record, which is just a JSON, really fancy JSON, but some of the fields in that JSON are meant to connect you to other parts of the FHIR record repository for that patient. But what if I could do the thing I just explained with FHIR records? So what our team did was take FHIR records and turn it into a knowledge graph using Neo4j if you're familiar with graph databases. So now I can take what I explained to you just earlier about RAG, which uses a vector index, and apply a graph database on top of that. So let's say I need to look up information quickly that's authoritative. RAG helps me do that. But what if I need to traverse to some other information? The way RAG works under the hood is it's using a cosine similarity to say, here's what the clinician is asking for. This is the closest thing to that in the RAG database. Let me answer according to that. Well, now I want to know something adjacent to that piece of knowledge. Okay, Tommy had stitches. Why did Tommy have stitches? So Tommy had this prescription. Why did Tommy have this prescription? Well, I could also use RAG to find that out, but all I'd be doing is using a semantic traversal to say, what other thing sounds a lot like the thing the person just asked for? Well, what if I could traverse an actual graph to say, this isn't just kind of related, this is exactly how this is connected. This new piece of information I'm telling you about is connected to the previous information you had in the following way. So that's the power of the graph database. So this is an actual FHIR record for Tommy represented as a graph. If you're not familiar with graphs, by the way, so a graph is just edges and nodes, and so if you and I are connected on LinkedIn, I'm a node, you're a node, there's an edge that says I'm connected to you, there's an edge that says you're connected to me. That's graphs in a nutshell. So here we have all the FHIR records, the events like a patient visit, an encounter, a prescription, a treatment, or a test. All of those are the nodes, and the edges are how those are related. This prescription was because of this encounter for this patient. This test was because of this encounter. We did this prescription because of the findings on this test on this encounter. So you can traverse the graph and come up with actual authoritative data, and then let your LLM spit it out in a nice, easy to digest and use way. So we talked about data, knowledge, and process. So now what if we could prompt for knowledge? So here's Tommy again. Tommy's got elevated blood pressure. I could go to the clinical practice guidelines. If the video weren't here, you would see this scrolling for about 23 seconds. It's a lot of information. I really respect people that can memorize this much information and be a good clinician. I think I would go crazy. It's a lot of data. Within that piece of information, though, there's actual process information. Okay, so this is an observation about Tommy's blood pressure. That's relevant, but I need to put that into context. Is this the first time I've ever seen elevated blood pressure with Tommy? Did Tommy just eat something really salty 5 minutes before I'm seeing him? Or has he been in here a lot with high blood pressure? So that's relevant. So what if we could take all that and distill it down into a process? So this slide shows basically the idea of a graph database applied to the process document. So this is the patient management on the basis of Office BP and 4 different possible outcomes. Is this the first time I'm seeing it? Is this normal? Is this elevated? Or based on the history of having hypertension stage 1 and stage 2, and then what to do about it. And so what the team did was graph out what to do based on the clinical process guideline. So if the guideline says to do X, Y, Z, well then based on, okay, this was the elevated blood pressure, this is the third time in a row, here's the guideline for that, and here's the nodes and edges around that. So then here's Tommy's history. He's been here 3 times, he's had elevated blood pressure every time. We can actually use natural language processing to find out all the clinical facts from this. It's very interesting to note that 500 people writing a note about a patient will write it 500 different ways possibly, right? You can't be certain that they'll use exactly the same terminology or exactly the same phraseology. So in this case, it's the John Snow Labs that we used to get all this out. So now I can find out, regardless of who the clinician was, exactly what the history was for this patient. So now I've prompted for knowledge, I know what to do, but what do I do next? What if I can prompt for process? So let's enhance this guideline. What we did, the video won't play, so I'll just tell you what we did. We took the entire process, fed it into a large language model, and got it to spit out XML that describes the process we're supposed to follow. And then we fed that XML into Trisotech to get the image on the right. If you're not familiar with that, Trisotech is one of many tools that we use often to, on the one hand, display clinical process in terms of business process notation, but also it can actually connect to your EHR system. So if you say, yes, this is the process, and the clinician says, yes, I agree, this is the next thing to do, go, 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 then the next few things can just happen on their own. So going back to what I was saying in the beginning, just truly automating the process. Yeah, those videos aren't playing, but this would be a nice pretty slide showing the Visio-like process that you'd see on there. So what does this all mean? If we bring this all together, understanding really what's not only what's in it for us if we automate things, but what do we get out of it? If I make it so much easier to follow the process the right way, to apply the right knowledge in the right time, to dig up the right data about the patient, think about the compliance impact of that. Think about the patient outcome impact of that. If you just make it that much easier to do it right, people have to go out of their way to fail to comply with the process. People have to go out of their way to apply a prescription in the wrong way, or follow the process the wrong way. So you're just making it that much easier for patients to succeed, for clinicians to succeed. We've only got a couple of minutes, so I want to save a few minutes for Q&A. So just on the closing couple of thoughts, operationalizing AI, like I've just described, is really actually hard. Over 80% of AI projects in the industry fail to make it to production, largely because they lack context. So I'm just giving you the context of how an AI project can actually get off the ground and actually make a real impact in a clinical setting. Projects that fail because the scientists doing the AI work don't know how they make it to production, they don't know who the stakeholders really are, they don't know if anybody wants this. So start with a context like this, and you can end with an actual production product. Quick plug for Red Hat Summit. If you want to hear more about this and have much longer discussions and even get hands-on, snap that QR code, come see us in Denver at Summit. It's going to be May 6th through 9th in Denver, Colorado. And I guess I have probably 1 minute for questions.